All right, everyone. I think we are good to get started here. Welcome to today's webinar on printing PCBs for hands-on learning. Just to kick things off, I thought we'd just go over the agenda for today. Today's webinar will be about 1 hour long. Feel free to post your questions in the chat box. Actually, not in the chat box. We've got a nice new QA feature, so look for Q&A and feel free to post your questions in there throughout today's presentation. I've got a couple of colleagues showing up as additional panelists who will be there and happy to answer your questions throughout. And then, the plan for what we'll cover today. Just starting off, we do have a quick announcement. We have a sale running right now on the V-One, and this is going to run until January 31st, where you can save $800 off your V-One purchase. If that's something you're looking to add to your equipment list, keep that in mind. The end date for that is going to be January 31st. As for the rest of the webinar today, we're going to do a quick project overview where we'll look at the full project of what we're covering today and go into a little bit of detail on each of the three boards. And then we're going to do a live demonstration where we'll be printing one of the boards from our project live, going through all the steps in the V-One software. And just showing you how easy it is to create one of these boards in just a little bit of time. And then if there's a little bit of time at the end of our webinar today, we'll be happy to answer some questions live as well. So again, make sure you're asking questions in the Q&A feature. That's where our team will be looking to answer those questions. We're also in the chat as well. If you've been to a few of our webinars before, usually this is where we jump right into kind of the slide decks and do a little bit of a project overview. I'm going to change it up a little bit today. We're going to do a little bit of bookending. So I'm going to actually jump into the software so that we can start getting to the probing step, start probing our board. And while the probing's working away, then I'll jump back to the slides here and we will kind of talk a little bit more about the project. So I'm going to switch over to the V-One software right now. And we're going to jump into kind of starting our live demo, and then we'll come back to the slides in a little bit. So I've opened up our V-One software here. And as you can see, it's a fairly simple user interface here. So we've got our nice Voltera logo in the middle. And then you can see we've got these 4 workflow tiles. So these are all the different workflows that you can run through on the V-One to produce prototype PCBs. So we've got the print workflow, which I assume you guys can follow along. That's for printing a circuit board. The solder step is for printing solder. And then in the heat workflow, we've got a couple of options. So this could be for baking our ink. This could be for reflowing solder paste, or just a manual heat if you've got another reason to do that. And then the drilling step is for drilling holes to do 2-sided boards. We're not going to be touching that today. We're just doing a single-sided board. So today we're just going to be focused on the print step. A couple other areas to keep an eye on in the software. So in the top right, we've got kind of all of our emergency action buttons. So our quick stop, our home the machine button, which will bring the V-One into its home position. We've got some settings and a couple other little buttons in the top. And then I do also want to highlight just in the bottom right. So this is in all of our websites, all of our software, all of our tools. We always have this little chat box available to you. So if you need to reach out to Voltera support, this is the best way to go about it. It's just right there and handy for you on any of the Voltera tools you're using. So to get things started today, I'm just going to hit print, and the software will guide us through all the steps. So I don't need to be an expert in the Voltera software. I don't need to read through the manual. I can just kind of follow along with what it's telling me. Now, as soon as we hit the print workflow, we're prompted to select what type of board we're wanting to print today. So whether we're wanting to do a simple alignment or a more aligned print. And you can see we've got a little bit of a description underneath each of these as well. So a simple print is where we're just going to place a blank board down onto our print area, and we're not too worried about how precise the alignment of our print is onto our board. We just need to kind of print somewhere on it, and we'll be happy with that. An aligned print is where maybe there's some existing features like holes or some other components that we need to make sure we've got some really nice precise alignment to. So that's where we would use the aligned print feature. But for today, I'm going to be printing onto just a blank board. So we're not too worried about that. So I'm just going to click that option for simple. And at this point, we are prompted to select the ink we're going to be using. Now, Voltera, the V-One ships with the Conductor 3 ink currently. But yeah, they do come in batches. The ink does expire over time. So I'm just going to give you a little bit of a demonstration here of what to look for on the label when you're going for it. So this is the side of the label. So we can see we've got our conductor. The material type is conductor 3 here. And so this is the name we're looking for in the software right now. So this is the lot name for it. So this is Frolicking Fairy. But there's other useful information here as well. So you can see I mentioned earlier the best before date. So we've got till October 21st next year to use that. And then we've also got storage instructions. So when we're not using the ink, it's best to keep it in the fridge between 4 and 10 degrees Celsius. So that's what we're looking for in the software. So I'll jump back over here. And we can see that I've already got Frolicking Fairy selected as one of my inks. If you don't see the ink you're looking for here, you would just click the Add Inks button, and all of our available inks are listed there, so you can add them to your library. But yeah, I'm just going to select that, and then we're brought into kind of the main workflow area of the V-One. So on the left-hand side, this is where all your user inputs are going to happen. Loading in files, telling the machine what to do. And then directly in the center, you can see we've got a work area that looks like our print area on the V-One. So that's what this is representing. And then in this blank space here on the right, you'll see in a few moments, we've got some helpful tips and tricks that will pop up throughout the software that just kind of give you some extra helpful guidance. Across the top, we've got a little bit of a progress bar on how far we are in the process. But the software is going to guide us through everything. So I don't need to be an expert here. I can simply just read what the screen's telling me to do and continue on. So here I'm being prompted to pick my circuit. So this is the file that we're going to be trying to print today. So I'm just going to click Choose File, and then I'm going to load it in for my computer here. And we're going to see that we're processing the file. And you'll notice it starts as orange. So that's the software recognizing this is a Gerber file. And then once it turns green, it has recognized the tool paths. And so you saw I zoomed in with the software. I'm just using the scroll wheel on my mouse to zoom in. But we can see all of our tool paths have been generated for our circuit here. So green is happy, and we're able to hit next. If there was an issue, we would have got a message of some sort dictating what problem we might need to fix, and the next button wouldn't be available to us. But yeah, we're happy to move along in the process here. So I'm going to click next, and the software's even preset to give us some general maintenance tips here as well. So we've got a little bit of a quality checklist here, excuse me, just to make sure that all of our calibration switches are clean. So I'm going to do that on my machine here. Just going to quickly take some isopropyl alcohol and a cotton swab here. And I'm just going to make sure that everything's nice and clean because this is where our tools measure. And so sometimes there's some material transfer that happens, and ensuring that area is nice and clean will make sure that our tools are measured properly. We also want to make sure that we've taken our ink out of the fridge and it's been had adequate time to warm up. So mine has done that, and I'm going to be using a fresh nozzle, so I hope it's not damaged. So I can tick everything off on those checklists and move on to the next step. Perfect. So we're prompted to clamp the board. So here's a great example of the helpful tips and tricks. So we've got a little bit of visual feedback here on what that clamping process should look like. But But yeah, so I've got my board here. I'm just going to switch over the camera. So I've got my large FR4 board here. So I'm just going to place it down onto our work area. Now, I've already kind of pre-placed the screw locations for this size of board, but my helpful tip is just to make sure that the clamps are level. That'll ensure that you get a nice even clamping. So count down the holes where you place the screws on both sides so that they're nice and even. Now on the clamp, we've got this little bit of an indent here. That is the clamping ledge. So that's what's actually going to hold our board down and keep it in place. So I want to make sure that I have that clamping ledge overlapping my board. So we can see I'm sliding my board underneath the clamp and it's being held in place there nicely. And then I just need to tighten down the screws. So what I'm doing is I'm pushing the clamp down. This helps us get a nice level board and just kind of loosely holding the board under the clamp as I tighten down the screws. And I don't need to over tighten these screws down. We're not doing anything extreme like milling where the board needs to be completely held in place so that even an earthquake couldn't move it. No, we just want to make sure that our board isn't going to move throughout the process of printing. And so finger tight is great for these. And for these larger boards, you can actually overclamp them and cause the board to do a little bit of a bow. And so that'll cause some deflection. But if you just do a visual check on the sides of the boards, that typically you'll be able to see if there's any of that deflection happening. And then I like to give it just a quick wiggle test to make sure that's not going to go anywhere. But the big thing here is we're holding it in place. So if we bump the machine, we're not changing our position when we do any alignment. Great. So I've got everything clamped here as the software is telling me. So I can click next. Perfect. Now it's suggesting I mount the probe. So this is Nova's probe, or sorry, the V-One's probe. So you can see there are a couple of magnetic mounting points here. And so those attach onto our rails here on the V-One. So when I am attaching, let's see, I just want to make sure that I'm rolling side to side. That'll keep these connection points from digging into the pins on the V-One. So I'm just going to connect it there and lock it in place. And we're ready to go. So nice, easy attachment with those magnets. If you've never printed with the V-One, they are a little stronger than you think at first. So just be prepared. With that mounted, we can click next. And like I mentioned, we're just doing a simple alignment here. So what's going to happen is I'm going to click the outline button. And the first thing the machine is going to do is it's going to measure the position of the probe tip. So it's going to measure on the Z switch first. And then it's going to go inside the XY positioner over here to get the exact center of the tool, because we need to know where the position of our tool is before we can interact with our board in any way. Perfect. So it's just working its way through that. And then what it's going to do is it's going to draw a hovered rectangle over our work area where we have our circuit placed on the screen, just to make sure we get some visual feedback that this simple alignment is where we'd like it to happen. Perfect. So I'm just keeping an eye on it, making sure that I'm not going to hit a clamp or I'm not going to fall off the edge of the board or anything like that when we go to measure. Now, if I wasn't happy with the position, I can always drag the circuit anywhere in our work area to reposition it. And then I can click outline again, and then the probe will then outline that new location. But yeah, either way, we've got plenty of real estate on this board, so I'm not too worried about the location at all. So I'm happy with this, so I'm going to click next. And the next step is probing our circuit. So you can see this is a decent sized circuit, so there's quite a few probing points. And the probing is important because we need to know the height map of our FR board before we go to print on it. Now, from just a quick glance, it may seem that an FR board is just extremely uniformly flat. I think that the glossy finish of it kind of helps mask that a little bit. But if you get really close up, it's almost textured like a golf ball. It's got a little bit of a texture to it. So we do want a height map that our dispenser can then follow later on. And so we're probing a whole bunch of points here, and we're basically creating a whole bunch of triangles that we can use to interpolate the height map in between the points. So this is going to take about 9 minutes, I believe. Yeah, 9 minutes, 44 seconds to go. So we're just going to let it go, and then I'm going to jump back over to the slides now while it's running. It'll still be in our bottom right-hand corner on the screen for you as we continue watching. So I'm just going to switch back over to the slides here. Let it run in the background. Perfect. So a little bit of a project overview for today. So the project we're running today was actually designed by our partners in Korea, ITIS, and their goal when they created the project was to help students gain an understanding and knowledge of PCB development. And this is mainly focused at an educational level, and they really wanted it to be using the V-One. So the project is completed using the V-One, and it consists of 3 single-sided boards that work together to create a digital number counter. So the number counter can go from 0 to 99, and we're able to change the speed at which it counts, as well as there's a reset button to restart the counter at any time as well. So now I'm just going to kind of talk through each of the 3 individual boards, and yeah. Perfect. So the first PCB is a voltage regulator. So on the left-hand side of the input on the board is where the board will take a power supply of 12 to 7 volts from a battery or power supply, and then the goal of the board is to output that into 5 volts. So on the right-hand side, the output powers to the other 2 boards. You can actually see there are 2 output circuits here. And this board was specifically designed to teach students the difference between linear type regulators and a switching regulator. So they can kind of test both the outputs to see the difference. So the second board is a pulse wave generator. So on the left side of the board, it takes the power from the previous board, and it had this circuit then runs it through a 555 timer chip that outputs a pulse. And so the power, as well as this new pulse signal, is then sent out the right side of the board to our final board, which will then use the pulse. So fairly simple board. This one's nice and easy to print. And then the final PCB is the number counter. So this is where we're rewarded for all of our previous work. So it contains quite a few number of ICs that take the output from the pulse as well as the power, and it triggers sequential counting on the 7-segment LEDs. So we're able to count from 0 all the way up to 99 on these 2 LCD or LED 7-segment displays. And we've also got a reset button that we can restart the counting back to 0 at any time. So I'm just gonna, while the machine's running, maybe I can show off the final printed boards, just kind of what they look like. So you can see them kind of strung together. Maybe this might be the best view. So here we have our power board. And these cases have been designed by our excellent applications technician, Devin. So thank you, Devin, for those. So these have some nice input jacks on either side as well. So that's the first board. Then we've got it running into the pulse board. And then finally, the 7-segment, the counter board there. So we're going to show this off at the end when I've got a little bit more space when the printer's not right in front of me. But yeah, just wanted to kind of highlight the finished product there for you as well. Awesome. So now that we've kind of done the project overview, I'll jump back to the V-One software and we'll see how far along in the probing we are. Perfect. So we've got about 4 minutes left. So a couple of things to highlight just here while we're probing is we can see the probing points that have already been completed. They are filled in blue, and so the remaining probe points are yet to be filled in. And then we can talk a little bit about, I guess, the settings of the probe pitch or the probe points. So one of the settings in the general settings determines how far apart these probe points are, which then determines how accurate or quickly you can probe a board. So it's going to be a trade-off when you're probing. The more points you have, the more time it's going to take, but the more accurate your height map will be. And similarly, if you have fewer points, it's not going to be as accurate, but it'll go very quickly. So the default setting that we have for this is here we are. So this probe pitch setting here by default is 5 millimeters. So that's saying the maximum distance between probing points should be 5 millimeters. So if we were to decrease this setting, that means the maximum distance is going to be closer together, which means we're going to have more probing points. So a more accurate height map, but it's going to take much longer to probe. And similarly, if we increase this setting and bump it up to say like 10 millimeters, we're going to have further away points, so fewer points, but a less accurate height map. So it will take less time, but yeah, be less accurate. Just going to take a peek through the questions and see if there's any worth highlighting here live. Thanks, team, for all your answers so far. So we've got one question from Marcelo David. My question is regarding the distance between the IC pads, for example. So I assume that might be a follow-up question. Yeah, what's the smallest size? So the minimum pin pitch for printing is 0.65 millimeters between, so that's your pin pitch setting. So that's the distance between 2 feet on your pads. And then for dispensing solder pads, that distance is a little bit smaller at 0.5 millimeters. But yeah, the smallest component you could place would have a pin pitch of 0.65 millimeters. Got a question from an anonymous attendee. Great webinar so far. Thank you. Will there be a Nova one coming soon? We would love to see the application for flexible substrates as well. Yeah. So I would assume our next webinar, since we've done a V1 today, our next webinar will highly likely be a Nova-based webinar, and that'll probably be in the new year sometime. Perfect. So we're just about done our probing here. We've just got a few points left here in this bottom left-hand corner, and then we'll be ready to move on to the next step. How many layers PCB can we print? Question from yeah, and so we can do two-sided PCBs with the V1. So you can print on one side, cure it, and then print onto the other side and cure that. And that's where that drilling function comes in. If you need to do any vias or through-hole components, you can use the drill to connect those two sides with some rivets. Perfect. So we're all done probing. So we can move on to the next step. So we're prompted to remove the probe. So I'm just going to take the probe off. Again, just being mindful of the pins that we don't damage anything. And click next again. So this is great. This is just guiding me through the entire process. So the next step is to prime our conductor. So this I will be upfront and honest with you guys. This is the biggest learning curve on the V1. Luckily, the next step can help tune that for you. But yeah, this is kind of where we do the learning. So we need to assemble our dispenser first. So I'm just getting everything prepped, and then I'm going to switch my camera over so I can guide you through assembling the dispenser. Perfect. So when we have the dispenser arrive, it comes like this in 2 pieces. So we've got the sheath, which we can slide our cartridge inside of. And then we've got the actuator side with the gear that drives things down. So as we dispense, there's a motor on the V1 that drives this gear that pushes the actuator here inside of our ink cartridge, and that's what does the dispensing. So before we assemble, we want to make sure this is fully backed off so that we don't accidentally inject any or expel any ink. And then I'm just going to insert the cartridge inside of our dispenser. And you'll notice that based on the geometry here, there's only one way to really get this in. And I usually like to do the label facing back, just so I can see the interaction with the piston inside here. And then one thing you want to just keep in mind is that we eliminate this little gap here. So we just have to push the cartridge one last little hard push to get it bottomed out. And then we're ready to insert the other end into the dispenser. So I'm just going to insert the actuator end in here, and then it's a quarter turn to lock it in place. And it feels nice and secure once you do that. And the last piece I'm missing is just a nozzle tip. So I'm going to grab one of those now. And these cartridges are the Nordson 5cc cartridges, and they use the lure lock system. So fairly straightforward to twist these on. So the dispensing tip, I'll just put in place and give it a little twist until it's nice and finger tight. And the tip is on. So that's an assembled dispenser. And so if we jump back over to the software, that's basically getting us to the point here where we're ready to do the priming of the conductor. So the goal here is we're trying to get the ink to a point where it's at the nozzle tip, ready to flow, but it's not flowing out or not behind. So that if we were to apply some pressure, ink would be able to dispense. And if we backed off pressure, the ink would stop dispensing. That's the goal. So we're trying to find that kind of right on the fence point in our pressure. So the instructions here, we turn the gear counterclockwise slowly till ink comes out, confirm the ink is coming out, and then turn the gear back in order to stop it flowing. So that's what I'm going to demonstrate here. Probably this view will be the best for that. So we can see with these clear nozzle tips that the ink's all the way back here. So I'm going to want the ink coming out the tip, flowing out a little bit, and then I'm going to back off the gear. So I will just start turning the gear counterclockwise. And it's going to be nice and loose until I feel the piston make contact with the actuator back here. And then we'll be able to start seeing the ink come towards the nozzle tip. So I just hit the piston. So you can see as I apply pressure now, the ink is making its way to the nozzle tip. And then finally coming out. So I've got flow, and so I'm going to back off quarter, maybe a half turn. I'm just going to do a quick wipe here, and then I'm just going to let it sit for just a second to make sure ink isn't still coming out. If it is, just back it off a little bit more, and then we can clean off the nozzle tip. Perfect. So that's the process of priming the conductor. And then we'll click next. We're prompted to mount the conductor. This works just like the probe. We've got our magnetic rail mounts, and we're all set. Perfect. And so now we're going to calibrate the conductor. So we're not assuming that you're going to do a perfect job every time that you prime the conductor, so prime the cartridge or the dispenser. So that's what this step is for. So we're going to print this pattern, and as we print the pattern, we're able to apply more flow or take away flow from the starting point of where we apply pressure. And so that will either, if we're seeing too much ink coming out, we can dial things back, or if we're seeing not enough ink coming out, we can increase things. And we can make those changes on the fly as it's printing. So yeah, we can just keep an eye on things, and we can print this pattern as many times as we need to get things dialed in. As a new user, there's nothing wrong with doing this 5 to 10 times to get things dialed in. If you're an expert user, you might be able to do it in 2 or 3 tries. So let's just hit calibrate, and the V-One is going to measure the dispenser now on the calibration switches. So we can see that happening. So again, it's getting the Z height. And this is where you can see how the material transfer can happen to those switches. So important to keep those clean before and after every use of the V-One. Perfect. And once it finishes measuring there, it's going to go and start printing. So I'm just going to switch over so you can see that. And so I'm looking for things like stringing between features and that our lines look full enough. Um, yeah, I'm not seeing too much stringing. And then when we go to print the individual lines, there we go. So I just did stood up and took a quick peek at it. We've got the four lines at the top. They're a little too close together, so I'm just going to back things off, maybe two or three, and then I'm able to wipe the ink off the board here. And if you get it pretty quickly, it usually comes off pretty nice. Feel free to use isopropyl alcohol if it's being a little bit stubborn. But yeah, I can calibrate again. And like I said, you can do these changes on the fly as well. So if I notice the first feature is not printing great, I can hit minus right away, and that change will take effect for the next feature. Okay, I'm just going to back it off. Maybe one more, and then we'll be all set here. So you can see our calibration pattern there is all finished printing. And so again, I'm just looking for making sure there's no stringing between the features as we move. So between these features mainly. So this is the kind of the direction it prints. It prints this feature first, then this one, then goes back this way, and then it goes through the four lines. Perfect. But yeah, I'm happy with those print results. So I'm just going to wipe the board here. Actually, I'll click next, and then the software will let me know to wipe it clean. Perfect. All right, nice and clean. So I have wiped the board clean, and I can click next again. And now we're just going to start printing. So there's a couple of things you'll notice here as well. So again, we still have the ability to change the starting point for our flow on our dispenser. So if we start printing and I notice, oh, you know what, it's still a little too runny for me, I can back it off even more. Or if I notice some features are a little thin, I can increase things. So we can do that on the fly as we're printing here still. And I do want to mention, so I've gotten things pretty close with the calibration. So I only had to go to -5. This value isn't a setting that is going to be consistent from print to print. It's all relative to how you primed the cartridge. So if I took this off, twisted the dial, this number is now going to be irrelevant to me. So yeah, it's going to be relative to how you do it each time. So I've seen -5, but I've also seen like -30 before, or +30 to get things to where they need to be. So yeah, don't be afraid if you need more flow to keep increasing until you see the flow you like. It's all relative to how you primed that cartridge in the first place. We can also see in our little helpful tip here in the top right that we've got some multiple or selection control here. So we don't have to just go ahead and print the whole circuit. If we wanted to just print a portion, I could drag a box and just print that portion. I could hold shift and select another feature to print as well. So we've got those options here available to us. But I think for me, I'm happy to print this whole circuit today. So I'm just going to get things back in the view for us, and I'm just going to select everything. But this is really great if you notice maybe one feature didn't get printed. You can always, at the end of your print, go back, select that feature, and try and reprint it as well. So there's a little bit of room for error for you here. But yeah, To get printing, I'm just going to hit start and we'll watch the dispenser do its thing. So it's been a little bit of time since I was talking. So the tool is just going to remeasure itself here. But that's not a big deal. And once it's measured itself, it's just going to start working its way through the printing. And yeah, we'll be able to watch that here on camera. So I'm going to keep an eye on things as well and make sure that the features are coming out the way I want. So you might see me click plus or minus here to adjust things as well. Um, and I think with this file, it's nice. It usually starts with the text. So um, it's usually a good way to keep an eye on things too. But yeah, it's looking pretty good for me. Perfect. All right, I'll give you guys a little bit more of a close-up view here as it's going as well. I'm just taking a peek at the Q&A now, see if there's any questions worth bringing it up here. And keep the questions coming. It's great to see 20 answered questions so far. Very awesome. And I will tell you, you never get tired of watching the printer print. Yeah, it's very mesmerizing. One thing you might notice as the the V-One is printing here, that even on these kind of continuous traces, it stops at a point and then continues on. So that is known as the trim length setting. So that setting controls how long it can go before it needs to stop and repressurize. So the V-One, we like to think of it a little bit like an analog watch. So there's no pressure feedback that's happening here. We've just kind of tuned the settings so that we know how much to move the gear to dispense, and so that distance it can travel before needing to repressurize. We've figured that out through experimentation with this material, and so as the material stops shearing, we need to then add a little bit more pressure. So that's why you'll see that stop and go. But yeah, this is printing really great so far. So we've got a question about one conductive ink syringe or dispenser. So yeah, the cartridge. How long can of a trace can it draw? So I'm assuming you mean just how much material is there in the cartridge, and how long can that go? Um, yeah, so our default Hello World board, we've determined it can do about 80 of those, but it really depends on how often you're stopping and starting as well. So if you end a print session, there's going to be a little bit of wasted material that's stuck in the end of the nozzle. But yeah, by distance, it's about 100 meters of trace. With your typical settings, that'd be kind of the most you could get out of a cartridge. Another great question from Mateo. Do you provide DRC rules? Those are design rule checking in PCB software. Yeah, we do for Eagle. So you can go to the support docs for that. So that's just docs.voltera.io. That can be accessed from the main menu of our regular website as well, voltera.io. But yeah, if you go to the support docs, go to V-One, then on the left-hand side, scroll down to the Eagle section. Yeah, we've got some DRC rules that you can download for the V-One there. I've got another question. What is the material of the ink? What's the ink made of? So this is a silver-based ink. So there are silver flakes and silver nanoparticles in this ink. So this is a semi-sintering ink. And so then when we heat up the ink to cure it, all those flakes and particles align to make the ink conductive. So typically the ink is made up of three portions. So your conductive material, in this case, silver, and then some sort of curing material. So oftentimes it's a resin to get it to hold its shape, and then a binder to kind of keep it in the state that we want it. So typically that's a solvent. So those are usually the makeups of the ink. Oftentimes the ink manufacturers are pretty keep their cards pretty close to the chest on exactly what those values are of what each material. Yeah, but that's kind of the idea of what makes up the ink. So this is a silver-based ink. Got a question from an anonymous attendee. How about using a 100 micron nozzle using the V-One? Um, So nozzle uh, inner diameter isn't the only thing you want to worry about. It's also nozzle geometry. So you can see this is a conical shaped nozzle. There's also straight barrel nozzle tips as well out there. The straight barrel nozzle tips typically require a little bit more pressure. I would if you wanted to experiment with a 100 micron nozzle, you certainly could try, but I would go for a conical shape one like the Subrec ones we carry in our store. The one thing you will want to just take note of with 100 micron nozzles is it is much closer to the particle size in the ink. So typically we recommend a nozzle size 6 times or larger than the average particle size in your ink. So it's getting a little tight with a 100 micron nozzle in this ink. So you will notice that it clogs pretty quickly. And just the 100 micron orifice that it comes out of, the ink can tend to dry fairly quickly in that as well. So feel free to give it a try, but you are going to go through more nozzles more quickly just with clogs and the ink drying. So yeah. Got another question about how can the room temperature affect the printing process? Yeah, it definitely can. This is why in one of the steps we recommend pulling the ink out of the fridge at least 15 minutes. I mean, I think half an hour is probably even better practice before you go to print so that your ink can come up to temperature. But yeah, the room temperature variability will change a little bit how the ink behaves. At warmer temperatures, it might be a little bit more runny, and at colder temperatures, it might not flow as well. So definitely something to keep in mind. But yeah, we recommend printing at room temperature, so 21, 22 degrees Celsius, 72 Fahrenheit-ish. So we got the question again, how many layers can we do using the V-One? Yeah, so I answered this a little bit earlier on, but the V-One can do two-sided PCBs. So you'd print on one side, cure, and then you'd be able to print on the other side. And if you needed to connect those two sides of the boards, that's where the drilling feature comes in. So you can use the drilling to do vias or through-hole components, as well as rivets to make that connection between the two sides of the board. Okay, I'm just going to switch back over to the software view to see how much time we have left on the print. Okay, about 4 minutes. Perfect. I'll let you all keep watching the print happen here. I've got a question about what other types of nozzle tips do you provide? Excuse me. Is there any difference in printing when different nozzle sizes are being used? Yeah, so for the V-One, we really like to see it as more of a plug and play type machine. So we ship the machine with these plastic disposable nozzles that you see here. So these are about 230 microns at its diameter. And unless you have a very specific reason to change from that size, I'd recommend just kind of sticking in that range. If you need a little bit more precision, you can move to the 225 micron metal subrex nozzles. But yeah, unless there's a really specific reason and maybe you're doing some experimentation or something, and you need to move to a smaller nozzle size, I would just stick with those. Great question from Chien. I saw you do the calibration at the center of the substrate. Can I define the area I want to calibrate instead of printing the lines at the center of the board? Currently, no, it just happens at the center of the board. But yeah, that's some great feedback. We appreciate it. So Max has a question. Are there different recommended applications for conductor 3 versus solder paste? Yeah, so conductor 3 is going to act as the traces of your PCB. So we're really replacing the traditional copper pads that you would see on a traditionally manufactured PCB. So that's what they are good as acting as. And solder paste is going to act as solder paste. So it's going to be more or less the glue that attaches our components to our board. So yeah, solder paste can be applied on top of conductor 3 once conductor 3 has been cured. So that's how we would manufacture this board. And then that's how we would attach the components, and then we could then reflow the board and get that solder paste to adhere all the components. But you can also use solder paste on traditionally manufactured boards as well. So the V1 could be used to help populate traditionally manufactured boards as well. Okay, we're just about done printing here. And then I can show off the final boards here for you all. Perfect. It is all finished. So we can do a little bit of a visual inspection on the board. I would typically recommend leaving it clamped in place while you're just checking to make sure everything connected the way you're liking. But in this case, I'm just going to pull it out of the clamps so we can get a little bit of a closer view here. But yeah, we got a really good print. Sorry about the light reflection there. I think that's maybe probably the best way to go about showing you all. But yeah, really happy with the final print quality there. Yeah, so I'm just going to get that out of the way. And I'm going to close the V1 software now. So the next step would be to bake the board. So it's suggesting we remove the conductor and leave the board upright, and then we would start the bake process. But for today, I'm just going to skip that for time and just switch over to our finished product. So I'm just going to get the software out of the way here, switch over to the big camera here. So I'm going to plug in my battery off camera. And so you can see I've plugged in my battery into the first board here. So this is our power regulator board. So our power is coming in on the left here and then going out at 5 volts here. So this is a 9-volt battery going into 5 volts here. And then our second board is where the pulse is being generated. So we can see, okay, if I could turn things around. So the power is coming from our power regulation board. It's going through the 555 timer. And then we've got visual feedback here of the pulse that's being generated. And that's being sent out the right-hand side of the board. And then that finally goes to our final board in the chain, our digital counter. So we can see it, the power and the pulse coming in, and then we just restarted counting. So kind of perfect timing for that. And so if we wanted to, we could press the reset button to start the counting at any time. But yeah, a very cool project with some great hands-on learning for students. With cases like these, great foray into 3D printing as well. So yeah, you can really have a nice finished form function here as well. So I'll just leave it counting there on top of the V1 for us as we just finish up the webinar here. So if you do have any follow-up questions after today, or maybe we didn't get to answering anything in the chat, you can feel free to reach out to sales@voltera.io. And we'd be happy to answer any follow-up questions you have there. And then additionally, I just want to remind everyone about the sale on the V1 running until the end of January, so January 31st. And then following up today's webinar, we'll be sending out an email to everybody who signed up with a link to a recording of today. So you'll have it for future use as well. And we're going to be sending out all the files for the project that we did today, including a parts list. So yeah, keep an eye out for that coming in the coming days. But beyond that, just want to thank everybody for joining us today. And yeah, it was great having you all here, and have a great rest of your day.